Encapsulation is good for me. Encapsulation is good, people say. I have encapsulated it all. Then come the methods. Methods are good. I will write more methods. I will add them all. You see, encapsulation is good for me. I am so happy. I can write 1,000,000 lines a day this way. It's all encapsulated here. Oh, it's 100 lines of code already. Well, that was fast. And I have barely started. This class will grow to 1,000 lines by Thursday, I guess. Maybe if I relaxed encapsulation just a little bit, it would end better. I've heard people say that a bit of relaxation is good when encapsulating state. I'm running the demo. I am so happy about it. Oh, what a nasty bug I've got here. This is ridiculous. If this is how you do encapsulation, then please check your inbox. You might have a message from the 1990s crying for you and begging you to return. Keep all the data private. Keep the operations public. Tell, don't ask. Yes, that was one of the big mottos. So many programmers got burned under it. This method here applies the tell, don't ask principle. You must tell the name of the author you are looking for. You must not ask for the searchable data structure of authors which you could query yourself. No, the data structure is encapsulated. That rule is sacred. To cut a long story short, the programmers of the time abandoned strict encapsulation. The choice was easy because object-oriented programming was either to change or to perish. Let me show you a more familiar form of encapsulation. Rename this collection to indicate it is an actual collection, but keep it private. Then expose a public read-only structure that would satisfy the needs of the callers but without the ability to mutate the underlying data. This simple idea has greatly helped contain the insatiable desire for more operations at the expense of making 1,000,000 bugs. We will come to that detail in a minute. The reduction in operations first. If only you could expose a useful read-only data structure to the consumers, you would certainly relieve your class from implementing a whole bunch of methods that just query its content. Why does this class which models a book have to search for the authors? Now that the authors are exposed as a sequence, they are searchable. Delete this method fix, the rest of the class, and get going. The class has just got a tad shorter and easier to manage. You might not believe it, but I have removed more than 20 lines of code after offloading this single duty to the consuming class. You can download this entire source code before and after the changes from my Patreon page. Being a patron is not just about code. Every registered patron enables hundreds of other programmers to view this content for free. Become a patron and help me maintain this channel free for everybody else. Now back to the question of bugs. Let me return that method so you can see what it was doing. It searches the collection of authors, trying to find one that matches the input string. Now that the sequence of authors has become public, I would expect all consumers of my class to implement this search expression. The trouble is that every now and then someone would forget to apply the correct culture to string comparisons. It was encapsulation that taught us to implement domain logic in one place and one place only. Then let the rest of the world call the method and enjoy its eternal correctness. And now that safety net is gone. You have learned so far about one giant issue related to encapsulation. It is a trade-off. On the one hand, it helps you avoid rampant code duplication and makes it easy to implement domain operations correctly. On the other hand, it forces you to write all code in the place where the data is, leading to enormously large classes. We learned to address this issue through the decomposition of classes. It was in 1994 when another great idea was cast in stone. Favor object composition over class inheritance. It is from the gang of 4 book on design patterns, but its significance goes way beyond patterns. What grabs attention is that 30 years before the present day, the virtues of object composition were already well understood. Why not compose the book object out of these small objects, plus the large one representing the list of authors? Why use strings and not proper objects? That was another great revelation in the distant past. In the blink of an eye, this once enormous class has melted to half its size. That is when encapsulation steps back in one more time. If, and only if, this other class, the author's list class, is encapsulated properly, so to guarantee its validity and correctness through the entire lifetime of an object, we can lift off access restrictions and let the callers manage authors using that class. Remove the read-only version of the data structure. Remove all the methods whose sole purpose was to delegate the call to the contained object. Enjoy the class's ultimate simplicity. Now it only implements methods that do not belong to its publicly available components. This explains how we got to that coding pattern, which many programmers see as the signature of C#. Public properties with private setters. That is so C#. You must have seen this a million times by now, and now you know when this coding pattern produces the correct code. Which reminds me of the elephant in the room. What if I still did it wrong? Oh, this coding pattern is wrong more often than you can imagine. The class you are looking at is modeling a book. A book includes the title, the culture, the list of authors, and the release. Then there's the release. Here is how I modeled it with another class full of public getters and private setters. The trouble hides in the only method it implements. This method apparently advances the book's release by one step. The caller supplies the publication date, but the edition must strictly step incrementally. Can you spot the problem? I might give you, let me see, 4 seconds to think. The time is up, and here is the answer. The edition property is relaxing encapsulation in a bad way. The interface is mutable. Even without the obviously mutating method, we cannot assume any concrete implementation will not be mutable itself. This discovery profoundly affects the release class, which depends on the edition interface. It must not only hide the property from view but also clone the instance it obtained through the constructor. This is the ultimate failing point of encapsulation. We are back to square one, which we know causes the proliferation of large classes, and large domain classes are one of just a few sure signs of bad design. Nevertheless, there is an easy way out. You can cheer up. We are observing a small problem here. It is confined to only a few lines of code. Why is it so small compared to the original issue I had with the book's authors? It is because of the object composition, or decomposition if you like. As you split objects into smaller ones, they quickly diminish in size. In only 2 hops you will be dealing with very small objects indeed. And guess what? Such small objects are easy to manage. Among other things, they are highly susceptible to the immutable design. Why not just say that every call to a method on the edition interface will return the new instance? C# does not support immutability guarantees, so this must be a conscious design decision. Once you get over that, the rest becomes easy. Immutable methods are usually easier to write than their mutable counterparts. Fixing the release class is now easy. Every change will cause it to detach from the prior instance. I can lift the restrictions again, making the edition publicly readable without fear of damage. If you can repeat what I did with encapsulation in this video, then you should also be ready to advance your knowledge of object-oriented design to the next level altogether.